People are saying that Spec Driven Development is just lightly sparkling Waterfall. And as someone who survived the actual phased software development lifecycle, I know that's just plain wrong. Here's why Spec Driven Development, or SDD, doesn't mean going back to the 1990s. I started my software career as a professional more than 20 years ago, at the time when the Manifesto for Agile Software Development had recently been published, which was a good decade or two after the ideas in it had first been tried out. It was a period when the phased software development lifecycle, or SDLC, was still the standard way of working in most software organizations, and the ideas from extreme programming, and particularly Scrum, were starting to become popular among a large wave of early-ish adopters. The SDLC is named after the biological life cycle, and as in biology, it's linear rather than cyclic. Software doesn't tend to reproduce and have offspring, so the cycle name is particularly misleading. Here's how it worked in one organisation I worked in back in the 2000s, which is representative of the general phased SDLC, or also known as Waterfall, approach. A project starts with a sponsor and a goal. That might be that the product manager wants to add features that match capabilities in competing products, that the CTO wants to productize a new development, or that the CEO thinks a request they got from a customer they met is particularly compelling. The company initiates a project, forming a team, and declaring that the project is in phase 1. The goal of phase 1 is to define the project. The team turns the idea into a product requirements document, or PRD, which is a matrix of the features and characteristics that the system needs to exhibit to deliver on the original goal. Each feature has a justification. For example, forecast additional revenue from new customers who buy the product because the feature now exists, and forecast revenue protected from existing customers remaining with our project and our product instead of switching to a competitor. Alongside the PRD, there'll be a needs analysis and a risk register. The needs analysis describes the resources required to succeed at the project, and the risk register explains what the potential issues are that could impact the project's delivery and the plans to mitigate them. When these things are complete, there's a phase exit meeting, which is the same at each phase, so I'll explain it once here. The senior managers meet with the project team, review the artifacts, in this case the PRD, the needs analysis and the risk register, and decide whether they're satisfactory and whether the organisation can support continued investment into the initiative. If everything's good, the project moves to the next phase. If not, it might get cancelled, but it's more likely that it fails to exit the phase, and the team needs to revise the artifacts and book another phase exit meeting once they've addressed the concerns. On to phase 2 then. When the team is fully staffed with people, or resources, identified in the needs analysis, they build detailed plans of the work they need to do and the time in which they expect to do it. From the developer's perspective, this is a system requirements specification, or SRS, sometimes called a functional specification, or FS, which shows what screens there are in the UI, what function every button does, what background processes there are, how each of these things links back to one of the rows in the PRD matrix. Similarly, the testers create a test plan, the writers create a documentation plan, marketing creates a marketing plan, translators prepare a localization plan. Some poor project manager has to enter all of this into a Gantt chart and work out how long it's going to take for the whole thing to be done and how much it's going to cost. Assuming we then exit phase 2 and get to phase 3, we're allowed to do some work. Coders code, testers test, translators translate, and so on. The goal of phase 3 is feature complete, where everything in the SRS is implemented in the system, if not fully baked. Phase 4 is system testing. Developers are fixing bugs, not adding anything new. Testers are integrating the whole system and checking mostly for integration issues. The goal is to achieve code complete, where there aren't any high priority defects in the feature complete system. Phase 5 is beta testing, where select customers get access to the product and provide feedback. Defects they raise are either fixed by the team or decided to live with. And then phase 6 is the release, and then you get into maintenance. fixing high priority issues that customers encounter in the field in a reactive manner. The project team is officially disbanded and people are just called away from whatever other work they're doing as maintenance needs arise, or a fixed amount of time is allocated for maintenance work and a fixed time for working on a new project. Of course, not everything is sunshine and roses in the SDLC, and sometimes, well actually most of the time, you find that those beautiful plans don't match what your customers now want, or that you can't build the thing that was requested and specified earlier. In these situations, someone needs to file a change request, or CR. That's a form that looks like it's supposed to help you change the project direction and the work involved and the estimates of completion date and so on. Its actual goal is to put you off making changes. The name of the process is change control. Each change is thoroughly documented, from the reason for the change through to the impacts on the plan, schedule, deliverables and cost, and then reviewed by the change control board, who either accept or reject the changes. This process is a death march, where you spend months on end polishing documents without delivering anything useful to your customers. In fact, when you do deliver something, your customers might not want or need it anymore. It does have benefits though, and the benefits of the SDLC have been less clearly explained, as a lot of people sought to present the phased SDLC as the bogeyman. Customers get a clear idea of the cost and schedule estimated for the initiative, allowing them to prepare for any training and deployment needs, as well as entering into a fixed cost arrangement with the supplier. Work is clearly traceable to its initiating requirement, and requirements are clearly verifiable in the delivered output. And the documentation involved lowers onboarding costs for new employees and captures institutional knowledge which would otherwise be tacit and retained in the conversational space between participants in the project team. Meanwhile, Spec Driven Development, or SDD, is a way of working with LLM coding tools. Vibe coding, by which I mean describing what you want to an LLM and getting it to generate code that does it, has risks, mostly associated with the imprecision of the initial prompt. Many well-constructed English sentences or sentence fragments have multiple interpretations. For example, the feature description, built-in security features, e.g. lights, alarms and bells. That's actually a feature description that comes from a real book on managing software requirements. But what are those features securing? Are the lights, alarms and bells physical items or virtual representations on a screen? Where are they located, with respect both to the thing that's being secured and the people responsible for its security? What threats does the system secure against? Are lights, alarms and bells illustrative examples or requirements? Is that an exhaustive list, or could there be more? SDD puts one or more intermediate phases between your initial idea, for example, built-in security features, e.g. lights, alarms and bells, and the code generation phase, where you work on a detailed description of the outcome that you want. Typically, you use the generative tools for these intermediate specs as well as the code. So you go from your vague description to a software specification, then from that to a task list, then to the code, using the generative tools at each step with the opportunity to review and refine the spec. That approach has benefits. Writing out the requirements gives an opportunity to discover and resolve ambiguities or inconsistencies in the idea, and you get more control over the code the LLM ultimately generates. The approach also has drawbacks. A lot of effort goes into maintaining the intermediate files, and it still doesn't address the technical side of vibe coding's problems, where the LLM piles up code that's difficult to maintain and doesn't demonstrate architectural consistency. But does adopting spec-driven development mean going back to the phased software development lifecycle with all of its drawbacks and its benefits? No. Here's the crucial distinction. Waterfall, a phased SDLC, is about people. SDD is about tools. You can do both at the same time, or one or the other, or neither. Waterfall, the phased SDLC, is a way to manage personnel, like a team of programmers, testers, translators and so on. SDD is a way to use a tool, like a coding assistant or an agentic code generator. You could use the tool within the project management paradigm. You could use a phased approach to software design, where managers review and sign off on all of the specs. Then, in the coding phase, the programmers pass the specs to a coding assistant and get it to generate the software. That way of working would have all of the characteristics of 1990s-style phased software development, except that the coding phase might be faster. It might be faster, in the same way that it might be cheaper, and it might create a desirable product. But you can also use Spec Driven Development within any other team dynamic. Consider a mob programming team, where the mob get together to co-create the LLM prompts, the mob co-review the specs, the mob co-integrate the generated code. Consider an extreme programming team, where people on the team identify things they don't know or don't understand in the specs and ask their customers what to do about it. You don't have to keep the markdown or other files you use in an SDD. You don't need to share them with your project manager. You don't need to get your senior leadership to sign off on them. But you could. In this way, SDD and a phased SDLC are entirely unrelated to each other, so the adoption of one doesn't mean accepting or rejecting the other. The way I work is to use Axminster with my coding assistant to maintain a model of my software for my own benefit, and use that model in concert with other techniques to generate task descriptions for the coding assistant to generate code that do look a lot like SDD specs. But I don't keep those specs. I might have them around for an hour or so while I'm working on a task, but I don't check them into version control. I don't keep them around. Once I know that the reviewed and tested code satisfies the design and behaves as I need, once I have applied both the U-review pattern to make sure that I understand the code and understand that it works, and the trust the tests pattern to know that the code behaves correctly because there are deterministic tests that validate its behavior, I delete the files I use to prompt the LLM to generate that software. The code becomes the ultimate source of truth about the code's behavior, just as if I'd carved it from raw keycaps. And there's a broader point to make here, and it's about the idea that people take to the internet and criticize choices of tools and interaction models that other software developers make in other contexts. It's that these criticisms, particularly when they're saying that adopting a particular tool or technique rejects the modern software engineering principles and takes us back to the Waterfall, to the phased SDLC, to a dark era of the software crisis, they fall into a common misreading of the manifesto for Agile software development. The argument seems to go that because the manifesto says to value individuals and interactions over processes and tools, and working software over comprehensive documentation, then putting any value or effort into processes, tools, or documentation must be wrong. That's not true. In fact, the manifesto explicitly says that there is value in those things. It also says that the way that you uncover better ways of making software is by doing it and by helping others do it. So don't be afraid to try new techniques, and avoid criticizing people because they are trying those new techniques. I'm interested to hear from other survivors of the phased software development lifecycle. What do you think about the way that AI tools are changing approaches to project management and team organization? Are they making those changes? Either comment on this video or go and join the chat over in the Chiron Codex Patreon, where a community of people who are interested in uncovering better ways of making software through understanding use of generative AI tools are hanging out and trying to become software centaurs by using these tools in a thoughtful way that enhances our understanding of software engineering. Thanks very much. Of course, please like and subscribe. This is the internet. I can't go without saying that. Take care and see you soon.